Hey guys, Mr. Beeler. Talking series and parallel circuits today. On top we have our series circuit. We spoke in the other video about series circuits. Everything's kind of in a line. We think like Christmas lights. Depending on what type of Christmas lights you buy. If one bulb goes out in the series, the whole strand goes dead. That is a series circuit. So as we follow along, we start our battery. We come through our fuse, our circuit protection device. I didn't put a switch in this circuit. This one's on all the time. We hit our first bulb. It is 4 ohms. We go through our second bulb. There's 8 ohms. We go to ground. Now to figure the total resistance for a series circuit, you just add the resistors together. So 4 plus 8, we're going to have 12 total ohms for that circuit. If we do Ohm's law, 12 volts equals amps times resistance. We know our volts, we know our resistance. Amps would be 1 amp for that circuit. Pretty simple in series circuits. They're all in a row, you add the resistances up. In a series circuit, as you add more resistance to the circuit, the amperage goes down, and those devices, be it bulbs or motors, will either dim or they will slow down as resistance increases. If we move into parallel circuits, we still have our 12 volts, we have our conductors, we have our loads. It's how the loads are laid out is different. So we follow through our voltage, we come up, we have a fuse, we come across. Now these two aren't tapped in line with each other. They get their own separate branches. They run parallel to one another. This bulb is 2 ohms, this one is 4 ohms. Now the math on this one's a little more difficult than series. We don't just add them together. There's an equation. There's resistance 1 or resistor 1 times resistance 2 divided by resistance 1 plus resistance 2 equals our total resistance. So we take 2 times 4, which is 8, over R1 plus R2, so be 2 plus 4 equals 6. So we would divide 8 by 6, which ends up being 1.333. Continuing, we'll just knock it down to 1.333. That is our total resistance for this circuit. In a parallel circuit, your total resistance should be less than your lowest resistance in the circuit. If you're doing my worksheets later and you come up with an answer on this and it's 3, it is too high. It's higher than your lowest resistance. If we think of as electric flowing through, remember electricity's lazy, it's trying to go half the least resistance. Well, some of it's going to try to flow, it's going to spread out, kind of like a shower head. They're all trying to find ways for the water to get out. They're going to flow through multiple legs. So 1.33 would be our total resistance for that circuit. Now, parallel circuits, we can add more legs to it. So let's say we run another line off, we come down, light bulb, ground, and this is a 6 ohm bulb. Now, this one becomes a little more difficult because we would figure our 2 and our 4, that was 1.33 combined for these two combined. So now we figure those two as 1.33 ohms. Now we just move along, same deal, we do another parallel, we got 6. So we're going to add 1.333 and 6. I'm doing this backwards, I got a multiplication on top. 1.333 times 6, which ends up being 7.998 divided by 7.333. Our total resistance ends up being 1.09 ohms. As we add more legs to a parallel circuit, the resistance keeps going down. Now, our amperage flow is going to go up. So if we're using Ohm's law, and we had 12 equals what times 1.33 versus 1.09, our resistance went down, our amperage went up. On a series circuit, as we keep adding stuff, the resistance keeps going up, our amperage is going to go down. Now on these circuits, we're going to do a little troubleshooting, basic troubleshooting on electrical. Let's get rid of all of our math here. I need a bigger eraser. So in our series circuit, if I have a fault, so in electrical, faults can mean a number of things. One of the more common ones you're going to see in the automotive industry is a component failure, so a bulb failed or a motor failed or a switch failed. Fuse is blown for some reason. Fuses blow for a reason. We have to find out what that reason is. We just don't go, oh, hey, fuse is bad. But then fuses blow because there was too much amperage draw. Another one you're going to see in the automotive world is a broken wire or cut wire. In this series circuit, if I go through and let's say this wire got cut, we can no longer flow amperage to those components. The bulbs won't work. Both bulbs won't work because they're relying on that same power supply. Now in the series circuit, so we have these three bulbs, we got bulb 1, 2, and 3. If I break this wire, these two guys still work. He does not. If I eliminate a ground, let's say bulb 2, you broke the wire for the ground. He will not work, he still will. Now if I break the wire up here before they all branch off, none of them are going to work. So depending on where that failure is going to give us some clues. So if I was troubleshooting the circuit, all three bulbs didn't work, there's a good chance before they split off we had a failure in our power getting there. There's also a chance maybe all three grounds are broken. Not as likely, or maybe all the bulbs are burned. Not as likely. If they all go out at the same time, most likely, what do they have in common? They all shared the power supply. So again, series and parallel. I'll see you next time.